You know what really gets me? And I mean really, genuinely, keeps me up at night gets me. You can't remember yesterday's breakfast, but you remember a song from 1987. Now most people hear that and go, yeah, funny, brains are weird. And they move on. But I can't move on. Because that right there on that little everyday thing is pointing at something so strange, so beautiful, so completely backwards from everything we think we know, that once you see it properly, you can never quite unsee it. So stick with me. I'm going to explain your own head to you. And I promise, I'm not going to use fancy words I don't need. If I can't explain it simply, I don't understand it well enough yet. That's my rule. Here's something that happens to everybody. You're at a wedding. Someone walks up, big smile, hand out, and you have absolutely no idea who they are. And inside your head there's this wild scramble, like you dropped your keys in a dark room and you're patting the floor going, come on, it's got to be here somewhere. Now, what do most people think at that moment? They think, my brain broke. They think I wasn't paying attention, I was distracted, something went wrong. But here's the thing I want to tell you right at the start, before we go any further. Your brain didn't break. It did exactly what it was built to do. And explaining why, that's what this whole thing is about. First, let me bust a story you've been telling yourself your whole life. You think your brain is like a camera, right? Or maybe a filing cabinet. Something happens, click. Brain takes a picture, files it away, and when you need it, you go and get it. Clean, simple, logical. That is completely wrong. Not a little wrong. Not wrong in some tricky philosophical sense. Just wrong. The way thinking the sun goes around the earth is wrong. Feels obvious, turns out to be backwards. Here's what actually happens. When something happens to you, say you meet somebody nice at a party, or you learn something new, or you smell something that takes you straight back to being 7 years old, a small group of cells in your brain start talking to each other a little louder. These cells are called neurons. You've got about 86 billion of them. And the little gaps between them, where they pass signals back and forth, those are called synapses. Now when you have an experience, some of those synapses get physically stronger, like a path through tall grass. The more you walk it, the clearer it gets. That is the memory, not a file somewhere, not a recording, just a path, a well-worn groove in the connections between cells. And the seahorse, here's my favorite part, there's a little structure buried in the middle of your brain, shaped just like a seahorse, called the hippocampus. That fella is the foreman of the whole operation. He decides, this one's worth keeping, that one isn't. Damage your hippocampus and you can still talk, walk, feel, but every new thing that happens to you dissolves in minutes, like writing in the sand, right where the waves come in. That's how memories get made. Beautiful, right? Now here's where it gets really interesting, because nobody talks about how memories get out. In 1885, way before computers, way before MRI machines, way before anybody had even invented the word neuroscience, a German fellow named Hermann Ebbinghaus did something that seems almost crazy when you first hear it. He had no lab, no funding, no team. He sat alone in a small apartment in Berlin, and he memorized thousands of lists of nonsense words, Dax, Bup, Loc, and then he tested himself, over and over, for years. Just a man, a candle, a notebook, and the peculiar stubbornness to use his own mind as the experiment. And what he found was this: 1 hour after learning something new, half of it gone. 1 day later, 70% gone. 1 week later, 90%. He drew that out as a curve. We still call it the forgetting curve. And 140 years of science has looked at that curve and gone, yep, that's right. Now, when Ebbinghaus found that, everybody said the same thing. Oh, memory just fades, like an old photograph. That's just what happens. Passive, natural, like rust on iron, nothing to be done. That answer stuck around for 100 years, and that answer is completely wrong. How do I know it's wrong? Well, let me give you a few little puzzles that the fading photograph idea cannot explain. And when a theory can't explain things, you throw out the theory. Puzzle 1. Why does a jingle from a potato chip advertisement you heard in 1987 survive perfectly for 40 years, but the most important conversation of your life, the one that changed everything, is gone in a month? If memory just fades with time, the bigger thing should last longer. It doesn't. Puzzle 2. Why does sleep, where nothing new is happening, nothing is being practiced, actually cause your brain to strengthen some memories and wipe out others? Rust doesn't selectively rust. Something is choosing. Puzzle 3. Scientists can inject a mouse with a drug that blocks a single tiny protein, one little molecule, and the mouse forgets something it learned yesterday. But memories from a week ago? Fine. Untouched. That is not random fading. That is a very specific, very deliberate operation with a very specific timeline. Puzzle 4, and this is the big one. The same parts of the brain that build memories are also active when memories are erased. Same machinery. The brain is using its own construction equipment to demolish its own buildings. You don't get that from rust. You only get that from intention. Every single one of those puzzles points to the same answer. Forgetting is not an accident. Forgetting is a job your brain does on purpose. All right? Let me give you a picture. Don't think of your brain as a filing cabinet. Think of it as a city, a huge, living, noisy city. 86 billion little residents all connected to each other, all talking at once. And a memory isn't a file in a drawer. A memory is a pattern, a particular way that a particular group of those residents are connected to each other. Like a neighborhood that grew up organically with its own streets, its own shortcuts, its own character. That's it. That's all a memory is. A shape in the connections. Now a man named Eric Kandel, he won the Nobel Prize for this and he deserved every bit of it, spent 40 years figuring out exactly how that shaping works. He used a sea slug. I know that sounds funny. A sea slug. But here's why he used it. A sea slug only has about 20,000 neurons. Your brain has 86 billion. You can't figure out a crowd of 86 billion by staring at it. But 20,000? You can map that. You can actually see what's happening. And what he showed is this. When a sea slug learns something, specific synapses, those little gaps between cells, physically change their structure. Proteins rearrange. New branches grow. The shape of the circuit actually changes. You can photograph it under a microscope. You can point to it. Learning leaves a physical mark on the brain. Now, there's a molecule in all of this called Qarib. Don't worry about the full name. Just think of it as the lock on a safe. When Qarib fires, it turns a short-term flicker of a memory into something solid, something that lasts. When it doesn't fire, the memory stays fragile, like scaffolding that never became a building. For years, scientists thought forgetting was just the building falling down on its own. Over time, naturally. Then something happened. In the early 2000s, researchers started finding something in the brain they weren't looking for, a little protein called RAC1. And when RAC1 switches on, something very specific happens. It goes to work dismantling synaptic connections, not weakening, not fading, dismantling, like a small, efficient demolition crew that shows up at a specific address in your neural city, checks the blueprints, and carefully takes the building down. And here is the line that stopped me completely when I first really understood it. Your brain burns energy to forget. It manufactures molecules. It activates signaling pathways. It does metabolic work. Forgetting costs something. It is not free. It is not passive. It is not rust. It is labor. Your brain is working right now, this very second, to let go of things it has decided you don't need. And here's the question that makes this interesting. Why would a brain do that? Why would an organ that took millions of years to evolve spend precious energy destroying its own records? That is the question. And the answer, well, stick around. For a long time, everyone assumed the same thing. Better memory equals smarter brain. More storage, more recall, more knowledge, must be better. Feels right, doesn't it? Well, let me tell you about a discovery that flipped that upside down. Your hippocampus, as that little seahorse we talked about, actually grows new cells, even in adults, even in old people. This surprised everyone. We used to think the brain you were born with was all you'd ever get. Turned out, no. New neurons keep arriving. Now, when a team of scientists at a children's hospital in Toronto started studying this, they expected to find that new neurons add new capacity, more cells, more memory space, simple. Instead, they found something strange. When new neurons arrive, they don't quietly add themselves to the end of the queue. They grow into existing networks. They disrupt connections that are already there. They physically interfere with memories that have already been stored. The scientists' first reaction was, that must be a flaw. Why would the brain do something so destructive? But then they looked at the animals that had high neurogenesis, lots of new neuron growth, and those animals were the most adaptable, the best at learning new things, the most flexible when the world changed around them. Their conclusion was not, neurogenesis is a mistake. Their conclusion was, forgetting is the whole point. Let me give you a picture for this. Imagine a dance hall. In a brain that never forgets, that just accumulates, the dance hall fills up. Old patterns frozen on the floor. Old dancers standing in position from years ago, taking up space. New dancers arrive, nowhere to go. The old choreography crowds out everything new. Now imagine the dance hall where the floor gets cleared. Old patterns released, space opens up, new things can happen. That is what neurogenesis does. That is what active forgetting does. A brain that forgets well is a brain that can change. And change, let me tell you, change is survival. The animals that made it through weren't the ones with the most detailed records of the past. They were the ones who could read the present and respond to it. Now here's something that surprised me even more. In 2022, a research group in Dublin published a paper asking a very simple question. When you forget something, is it actually gone? And the answer was, maybe not. Here's what they found. When memories seem to disappear, the neurons that encoded them are often still there. The physical pattern, the specific constellation of connections, may still exist, but the road to get there has been closed, not demolished, sealed off. Like a street that's been blocked, the houses are still standing, but you can't get to them anymore. You reach for the memory, and there's nothing there, but it might just be that the route has been blocked, not that the destination has been erased. We don't yet know why some memories get demolished and others just get locked away. We don't know what decides. That question is still open, and I find that, honestly, not just as a way of talking, one of the most beautiful open questions I've come across, because it suggests that what we call forgetting might sometimes be more like a door that's closed, not a wall that's been built. Now, I want to tell you about a fellow named Carl Lashley. He was a neuroscientist in the 1920s, and he spent 30 years trying to answer what seems like a perfectly simple question: where is a memory stored? His method was logical. Train a rat to run a maze, then cut out the part of the brain where the memory must be. Rat forgets maze. You found the location. Simple. He failed. No matter which part of the cortex he removed, the rats could still run the maze. Imperfectly, yes. But the memory wasn't destroyed. He went through every region, tested every possibility. Nothing. After 30 years, he published a paper basically saying, I cannot figure out where memories are stored, and yet they clearly exist, so I'm at a loss. Now, most people would read that and feel sorry for Lashley. All that work for nothing. But here's what that failure actually meant. The memory wasn't in any one place. It was distributed, spread across many regions at once. Not a file in a drawer, a pattern across the whole city. Lashley didn't find the answer. He found something better. He found out that the question was wrong. And realizing your question is wrong, that is one of the most important things that happens in science. It's not failure, it's the door opening. Now we go somewhere more unsettling. Because what we've covered, the RAC1 demolition, neurogenesis disruption, silenced engrams, that's the mechanism, the how. But underneath it is the question that makes this personal. Here is the fact. Every time you remember something, you change it, not metaphorically, structurally, molecularly. When you retrieve a memory, it becomes temporarily unstable. The act of remembering loosens the protein scaffolding, and the brain must rebuild the memory from scratch. This is memory reconsolidation. Karim Nader showed this clearly in 2000. If you recall a memory and then block the protein synthesis needed to rebuild it, the memory can disappear. The act of remembering without rebuilding creates forgetting. Let that land. Every time you remember your first day of school, your first heartbreak, your last conversation with someone you loved, your brain takes it apart, updates it based on who you are now, and rebuilds it. You are not retrieving a recording. You are reconstructing a narrative. And every reconstruction nudges the original. Elizabeth Loftus showed how deep this goes. People can be led to remember events that never happened with vivid detail simply by suggestion. In one famous experiment, she planted a false memory in about 25% of participants that they had been lost in a shopping mall as children. They didn't just accept it, they elaborated it. They added details and emotion. This isn't a curiosity, it's how memory works. Now consider what this means at scale. Think of the memory you most want to preserve, the one that feels like the foundation of who you are. Now consider, every time you've recalled it, you've been editing it, adding later experience, smoothing uncomfortable details, shifting the emotional tone to match the person you are now. The you who lived it is not the you who remembers it. That memory is a manuscript with many drafts, and here's the cascade. If your memories are reconstructed rather than recorded, then your sense of personal identity, built on those memories, is also reconstruction. The story you tell yourself about who you are isn't a document, it's a live performance, constantly revised. The past you believe you had is, in part, a story your brain is telling itself right now. Your autobiographical self is not a record. It is an act of authorship, not fake, not made up. The events happened, but the meaning, The shape of the story is crafted through present emotion, present belief, present need. There's a Borges story about Funes the Memorious, a man who could forget nothing, every leaf, every cloud, every sensation, preserved perfectly. People assume that would make him brilliant. Borges concludes the opposite. Funes can't think, he can't reason, because thinking requires abstraction, pattern, meaning, compression, but Funes is trapped in endless detail. A perfect memory is not the apex of cognition, it can be its end. The reason you can read these words and build meaning from them is that your brain can discard most of what it encounters, compress it, generalize it, let go. Forgetting is not the price of failure. Forgetting is the price of intelligence. There's a moment when the science becomes personal. We started with not remembering someone's name. Now we've walked through demolished synapses, sea slugs, and the architecture of identity. So let's come back to what it feels like to live in a forgetting brain. I think about the losses people mourn, the grandmother's voice you can't fully hear inside your mind anymore, the smell of a childhood kitchen that's thinned into nothing, the exact words of a conversation that changed your life, now reduced to a vague residue, like the shape a cup leaves in sand after the tide comes in. Those are real losses, grievable. And yet, here is what I've come to think. Not being able to replay your grandmother's exact voice doesn't mean the experience left you. It means it was integrated, distributed into who you are, into what comfort sounds like to you at 3 a.m., into how you recognize warmth, into how you respond to kindness. The recording is gone. The person it shaped remains. You are not a recording. You are a consequence. A recording can be destroyed. A consequence cannot. But there's another side, and it's disorienting. The idea that my sense of continuity, my feeling that I'm the same person who made a choice 20 years ago, who loved that person, who carried that wound, is at some level a performance. Reconstructed each morning by a brain that has been quietly editing the manuscript while I slept. That's unsettling. I don't want to rush past it, but if you stay with it, it becomes something else. Because if memory is reconstruction, then the story of your life is not fixed, not a sentence already passed, not a verdict carved in stone. It's a living document, and living documents are revisable, not by pretending, not by denying, but by the biological fact that every time you remember, you open a narrow window where the story is unstable and then saved again. Now I want to tell you about Henry Molaison, known as H.M. In 1953, doctors removed his hippocampus on both sides to treat severe epilepsy. The surgery reduced seizures. But Henry could no longer form new long-term memories. For the remaining 55 years, every day was new. He woke not knowing where he was. He didn't recognize nurses who had cared for him for decades. He didn't remember his mother had died. He didn't know he had grown old. Each morning he met the world without a yesterday to stand on. And sometimes he said something that brought rooms to silence. Every day is alone in itself. I still don't know whether that's the most heartbreaking sentence or the most quietly free. Most of us live weighted by yesterday. Failures, histories, identities built from old drafts. Henry had none of that weight. He had only now. He lost what we think makes a person continuous, and yet he remained by every account gentle and warm. Whatever we are at the core is more than memory holds. So what do you do with all of this? Not in theory, in practice, on Monday morning. Here's what the science says, plainly. Forgetting is one of the few biological processes you can work with, not defeat, not trick, work with, like a sailor works with wind. First, Ebbinghaus's forgetting curve is not a verdict, it's a schedule. If you review something once within 24 hours, even briefly, the curve resets. You reactivate the circuit, you reinforce the proteins, the building goes back up stronger. That's spaced repetition. Review at increasing intervals, so the brain strengthens the memory before the scaffolding degrades. A 2008 meta-analysis across 254 studies with over 14,000 participants found spaced repetition improved long-term retention by about 200% compared to cramming. Second, sleep is not a pause. Sleep is your brain deciding who you're going to be tomorrow. During deep sleep, slow-wave sleep, and REM, your hippocampus replays the day to the cortex, selectively. Important, emotional, relevant material gets strengthened and moved into long-term storage. The rest is cleared. Sleep is editorial work. There is no cognitive function we know that isn't degraded by sleep deprivation, and memory consolidation is one of the most affected. Matthew Walker's work has emphasized this. You are not just resting. You are editing yourself. Third, because memory is reconstructive, how you tell your own story matters in a biologically real way. When a painful memory is recalled, it enters a reconsolidation window, unstable, during which its emotional charge can be altered. Resilience studies repeatedly find that recovery is not about deleting the wound, but reconstructing it with context and meaning so the memory rebuilds with less threat response. The event doesn't change. The story of the event changes, and that story changes what the memory does to you. You cannot rewrite what happened, but every time you remember it, there is a narrow, molecularly real window where you are not just recalling the past, you are writing it. So here are 5 things to carry out of this room. 1. Review anything you want to keep within 24 hours. 10 minutes is enough to reset the curve. 2. Protect your sleep fiercely. You're not resting, you're consolidating who you're becoming. 3. When something painful rises, notice. You're not watching a recording, you're rebuilding. 4. Release the guilt of forgetting. Your brain isn't broken, it's doing what it evolved to do. 5. The memories that mattered most aren't stored as files, they are stored as you. Your instincts, reflexes, humor, attention, kindness, and boundaries. The best of what you lived is not in recall, it is in character. Let's take stock. We started with a name you couldn't remember at a party. We ended with the architecture of identity, rebuilt every morning by a brain that has been quietly editing your autobiography while you slept. We learned forgetting isn't passive decay. It's work, metabolically expensive, molecularly precise, evolutionarily useful work. We learned remembering is editing. We learned the self is not a record, but a performance, ongoing, improvised, revised. We met Ebbinghaus alone with nonsense syllables and a candle. We met Kandel and the sea slug. We met Lashley failing his way into distribution. We met Nader showing recall makes memory unstable. We met Loftus showing how suggestion can shape recollection. We met Borges's Funes, crushed by perfect recall. We met Henry Molaison, living with each day alone in itself. And maybe we arrive at something uncomfortable and liberating. The quality we mourn, forgetting, is also what makes it possible to change, to grow, to become someone you couldn't have predicted. The self is not a noun, it is a verb, and it is still being conjugated. An unsolved problem is an invitation to think. Now here is my question for you. Think of one memory, just one, that you've been carrying as evidence about yourself. A failure, a wound, a moment of loss or shame that's been shaping what you believe you deserve, what you believe you're capable of, who you believe you are. In light of everything you've heard, that memory is a reconstruction, not a recording, and every time you tell it, you become an author, not just a subject. How might you tell that story differently? Not falsely, not with forced optimism, just differently. Thank you for thinking about this with me.